Hey everybody, welcome to another fun and exciting Algebra 1 class. I'm looking forward to today. We're going to start into Chapter 2, so looking forward to kind of sharing some new concepts with you and just kind of see where that goes and see if we can learn some new stuff today. So if you will, just go ahead and turn to page number 46 in your books. And that's where we'll be starting off today, chapter number 2. Usually when students think about algebra, they think about equations. And so far, we haven't really gotten into any equations yet, although we've kind of started algebra and we've kind of gone into it, but we still haven't really done any equations. Well, today we're going to change that, and we're actually going to go into equations, check that out, and see what we can learn today. Okay. Today we're going to talk about what's called the addition property of the equation. The addition property of the equation is where you are adding in the equation. So it makes sense. Addition property is where you add. And what we're going to do is we're going to figure out what that means, what that looks like in our equations, and we're just going to do some real basic equations. Most of this stuff is stuff that you would have had in pre-algebra, stuff like that. So I don't think it'll be real challenging for you today, but you do need to get this. If you don't get this, you're going to struggle all the way through. Probably the trickiest part of this is the adding and subtracting of positive and negative numbers. If you're still not good at that, you need to brush up on that right there. So, all right, well, let's talk about, first of all, what is an equation? What is an equation? The equation is the idea of keeping something balanced. So if we put something heavy on this side, we also have to put something heavy on this side to balance them out. Or else if we put something heavy on this side and don't put something heavy on this side, it will not balance, okay? And your equation will be out of balance. So what does that mean for us? Every time we do something to this side, we must also do the same thing to the other side. If we don't, our equation is going to get out of balance, and we're going to have problems. All right. So let's talk about the basic parts of an equation. If you look down at the screen, I'll put a basic equation. We'll put x plus 3 equals 10. Okay? X plus 3 equals 10. Now, this x right here is called the variable. The variable. I think we've talked about that enough. You should know what that means. Now, these terms right here are both called constants. They are both constant terms. In other words, they don't change. 3 is always 3, 10 is always 10. You can't change that. X, however, is variable. X can change. So what we're going to do here is we're going to go ahead and work on this and see if we can figure out what x actually equals. And with the addition property, that means that whatever we do to the one side, we have to do to the other side. Now, the idea, the goal here is to get x all by itself. We want it to say x equals something. In other words, we want to get rid of that 3 over there. Okay? We want to just say x equals. Now, we can't just cross it off. Because if we could just cross it off, what did we just do? Now we've made it unequal because we took something away from this side and it made it out of balance. We can't just cross it off, but we can do something. If I had 3 pencils in this hand and I had 3 pencils in this hand, what if I take 1 pencil away from this hand? Well, that hand's going to go up because this hand with 3 pencils is going to weigh more than the one with 2 pencils. What do I need to do to this hand? I need to take a pencil out of that hand so that they can be balanced again. Okay, so if we take, watch what happens here. If we take 3 away from that side, if we subtract 3 from that side, remember, this equal sign is like our balance. I've seen some teachers put like a little thing there that kind of makes it look like a balance, like it would kind of like shift one way or the other based on what you're doing. And you can think that in your mind. There's a balance there, that it's like a point that it's balancing on. Now, if I take 3 away from this side And remember, this is like the balance right here. That equal sign is like the balance. What do I have to do to the minus 10? Well, I also have to take 3 away from the minus 10. And that's going to cancel. Or in other words, if I have 3 and I take 3 away, I have 0. I've canceled it out. It's nothing. Okay? And so all we have over here on this side is our x. And then we have our equals. And then we would do this math right here. 10 minus 3 is 7. Well, there's our answer. X equals 7. That's what we were looking for. We're always looking for the x to be by itself, to be all alone. X equals 7. Okay? And that is the addition property of an equality. Kind of short and simple there. It'll get more complex as we go, but that's kind of the simple version. We have to do some other things to follow order of operation whenever we have multiply, things like that. And we'll get to that a little bit later on where we actually have multiplication symbols and things like that. So let's do this. Let's skip over to page 47. You'll see there on page 47 there's a picture of the balance, okay, the scales. And so if you put something on one side, you got to put something on the other side to keep them even. It actually has on page 47 the addition property of equality written out, which all it says that if you add something to one side, you have to add it to the other. If you subtract something from one side, you have to subtract it from the other. Okay. All right. So let's do a couple more of these, and let's see what we can learn here. This example that they gave you is very simple. It's like the one I just did. Go ahead and look down at, sorry, my camera's messing up just a little bit there. Go ahead and look down at example 1.2c. It says n minus 10 equals 2. And you're like, wait a second, I thought that we had to use x. No, we can use any letter we want to as a variable. Any letter works, okay? N works, T works. I don't like T because it looks like a plus, but T works, S works, N works, W works, A works, B works. Okay, it doesn't matter. You can use really any letter that you want to. All right. So n minus 10 equals 2. Well, again, we are trying to get our letters on one side and our numbers on the other side. In other words, we're trying to get n all by itself. And so here you see we have to deal with this negative 10. So if we add 10, what happens here? If I have negative 10 and I add 10, what happens? I get 0. That's what I want. I want that to cancel out. And then I have to do it to the other side as well. Remember, if you do it to one side, you have to do it to the other side. So what do I end up with? Okay, I end up with n equals, and then I do this math right here, 12. And that's my answer. Let's see. Go ahead and turn the page over to page 48. Same thing holds true if we're dealing with fractions. It's just maybe a little bit more challenging, but it's not too bad. Y minus 3/5 equals 1/3. Y minus 3/5 equals 1/3. Now, again, what our goal is here is our goal is to get y by itself. Okay? So I want to take everything that's over here that's not a y, and I want to move it to the other side. I want to get rid of it. I want to cancel it out. So if I'm subtracting 3/5, what do I do to get rid of it? Well, I add 3/5. Okay? That will cancel that out. If I do the opposite sign, it cancels it. Well, then I have y equals, but I have to do something over here. I have to add 3/5 because I added it here. I got to keep it balanced, keep it even. Well, now I have a problem. My problem is I don't have a common denominator. Well, that's why you took baby math. That's why you took 7th, 8th, 5th, 6th grade math, is so that you knew how to find a common denominator. Some of you were really hoping that denominators wouldn't be an issue in algebra. Well, you were wrong. You were big time wrong. Denominators are a huge issue in algebra, and this is the very first time we're seeing it, but all through the book you're going to see denominators are a problem. Okay, and so we want to deal with this denominator. So let's go ahead and look at it. What is our common denominator? Well, the common denominator between 3 and 5, and I'm not going to show you how to do it because you should already know, is 15. And so 3 times 5 equals 15. So 3 times 5. And so 1 times 5 equals 5. So 5/15 is the same as 1/3. On this one, 5 times 3. 3 times 3 is 9. So I have 5 over 15 plus 9 over 15. And that is going to equal 14 over 15. And that would be our answer. Y equals 14 over 15. Now, let me show you something, and this is the check. This is how you always can check algebra. When you turn in an algebra test, you should really know, especially with your equations, I got that right. I know I got that right. Why? Because I checked it. How do you check it? Well, what you do is you take your answer and you plug it in, you remove the y, and you put your answer. So, 14 over 15 minus 3/5 equals 1/3. Well, that doesn't look super easy, but we can actually change them all into common denominators and we can make it a whole lot easier. So the first one doesn't change because 15 is the common denominator. Minus, and what was this one with 15 as the common denominator? We can cheat just a little bit and we can look back at what we got over here. Okay, so if you kind of look back and you're like, oh yeah, we already did that. Okay, so just use it again. 9/15 equals, what was the 1/3 with the common denominator? It was 5/15. All right, so let's see if we're right. Let's see if our answer is right. 14 minus 9 equals 5 over 15 equals 5 over 15. Is that right? Well, of course it is. 5 over 15 equals 5 over 15. So it's correct. We checked it. We verified it. We got 5 over 15 equals 5 over 15. What happens if we get something that's weird, like 1 over 15 equals 5 over 15? Well, that doesn't equal. So we've done something wrong, and we'd have to go back and figure out what we did wrong. Okay. All right. Let's do one more. We'll do one more with a decimal this time. No, I'm not going to do that one. Decimals are the same as fractions. I'm going to save time and not do that one. I'll skip to one with distributing. You're going to like this one because we learned how to distribute last chapter. Remember, in algebra, you can't forget anything. Okay? If you learned something last chapter, you're going to have to know it for next chapter. It's just the way it works. So x minus 3 equals x minus 4. You might think, wow, this one's complicated. It's not bad. It's really not. Let's just follow our steps. The first thing that we do in order of operation is we distribute. We multiply. Okay? Solve the parenthesis, whatever you want to call it. And so that would be 2x minus 6. 2x minus 6 equals x minus 4. And then what we would do next is we would just start moving the letters to one side and the numbers to the other side. So if you look here, we have a 2x and we have an x over here. So we want to move this x over to this side, okay, because we want the x's all together. So if we do minus x minus x, now remember, it's technically a 1 in front of that. The coefficient of everything is 1 if it's not written. So this cancels out. And then what do we get here? What's 2 minus 1? 1x or just x. Now we can do that. We'll do this in the same step. I'm trying not to confuse you, but I think you can handle this. I want to move this over here. I want to get rid of it. I want x to be by itself. So if we do plus 6 to that side and plus 6 to that side, because what we do to one side, we have to do to the other side. Cancel, x equals, because everything's canceled over there. And then remember, we took the x over to the other side, so it's just numbers, and then we would do this math. Negative 4 plus 6 is going to be 2 or positive 2. X equals 2 would be the correct answer there. Now, we can go ahead and we can check that. So 2 times x minus 3 equals x minus 4. Everywhere that there's an x, we're going to put a 2, okay, because that's our answer. 2 times 2 minus 3 equals 2 minus 4. Now we can do this either way. We can do the parentheses first, or we could distribute. We'll get the same answer. We showed you that before. We'll do inside the parentheses first, okay? What's 2 minus 3? Negative 1. So 2 times negative 1 equals 2 minus 4. What is 2 times negative 1? It's negative 2 equals 2 minus 4 is negative 2. We checked. And it does check. So we got the answer correct. Negative 2 equals negative 2. And so that means that we were right. X does equal 2. Okay. All right. Well, there you go. I hope that was helpful. Hope you learned something today. If you struggled with any part of that, go ahead and watch the video again and see if you can get it this time. Okay. All right. We'll see you later. Bye-bye.